Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology. Subject code OEC 754, Unit 4, Biotelemetry. Objective to learn about the concepts of biotelemetry and its different types. Biotelemetry system used for the purpose of measuring the functions like body temperature, heart rate, blood pressure, and muscle movement. Here, the biotelemetry is a particularly important because it can be used to remotely track the vital signs of ambulatory patients. Then the categories of biomilitary system. There are two categories have been done in biotelemetry measurements. They are active measurements and passive measurements. In the active measurements, bioelectric variables such as ECG, EMG and EEG. And the next one is a passive measurements. Here it is a physiological variables that request transducer such as blood pressure, gastrointestinal pressure, blood flow and temperature. Next one is single channel telemetry system. Here it shows the block diagram of a typical radio telemetry single channel system. It consists of radio transmitter and receiver. In this, the telemetry receiver consists of a high frequency unit and a demodulator. It also contains an electrocardiograph to record a cardioscope to display and a memory device to store the ECG. Here the radio frequency range used in the system varies from 100 kHz to 300 MHz, and if the frequency beyond this limit, attention becomes excessive. Therefore, either frequency modulation or pulse modulation techniques are used to transmit the biosignals. Then the following methods are some of the telemetry circuits. The first method is tunnel diode FM transmitter. Here the above diagram, which consists of Varakotter diode, tunnel diode and indicator. In this, the tunnel diode exhibits a specific characteristics of negative resistance, and then the tunnel diodes are used as active devices. Here we have some low value capacitance and inductance are used for the transmission of EMG, ECG and EEG respiration rate. Here, the signals are transmitted through the inductor L in the tank circuit of RF oscillator. It is a basically reverse biased PN junction which utilizes the inherent capacitance of depletion layer. Here we have in the tunnel diode FM transmitter, it has higher fidelity and sensitivity. All the signals can be transmitted normally. The next one is Hartley type FM transmitter. It is the method used for the transmission of ECG, EEG and MG. Here LC is a tank circuit. It is used to generate the signal which is used for the oscillation, and a specified frequency can be designated. So therefore, bandwidth of signal is varied from 100 Hz to 1 kHz. Here the amplitude of the input signal may vary from 10 mV to several millivolts, and transmission range is usually from few meters to 30 meters at a power consumption level of milliwatts. Here the pulsed Hartley oscillator, that means this method is used for the transmission of temperature, signals, pressure continuously for long periods. Here the thermistor is placed in the place of R to measure the temperature. Then the pressure changes should be taken to move the core M to measure pressure. And the electrodes are connected across the voltage input to measure the pH or voltage. Then the transmitter connected with the supply 1.3 volt is used to vary the rate of pulse radio frequency oscillation. So only the continuous wave operation can be obtained by reducing the value of resistor R. Here we have one advantage, that is power consumption is very low. Then next one is multi-channel telemetry system. Here the signals are to be transmitted simultaneously is difficult in single channel transmission. Therefore, multiplexing technique is used in telemetry. There are two types, FTM and TDM. First, we are going to see the frequency division multiplexing telemetry system. That means each signal is frequency modulated on a sub-carrier frequency. Then the modulated sub-carrier frequencies are then combined to modulate the main RF carrier. Here, at the receiver side, the modulated subcarriers will be separated by the proper bandpass filter after the first discrimination. Then only the individual signals are recovered from this modulator subcarrier by the second set of discrimination. Then the frequency of the subcarriers has to be carefully selected to avoid interference. Therefore, an exact signal without any noise is obtained by using a low pass filter. Next one is time division multiplexing telemetry system. It is a method for sharing the signal in a low frequency bandwidth requirement. That means the transmission channel is connected to each signal channel input for a short time to sample and transmit that signal. Here, then the transmitter is switched to the next signal channel in a definite sequence. Here, the process is reversed at the receiver side. Then the sequentially arranged signal pulses are distributed to the individual channels by a synchronized switching circuit. Then the transmitter and receiver are synchronized when the number of scanning circles per second is large. Therefore, the signal in each channel at the receiver side can be recorded without any distortion. Thank you.